So what is agrivoltaics? There is a quote from the research center Fraunhofer in Germany, Fraunhofer Institute for Solar Energy Systems, that says agrivoltaics is as diverse as the farming sector itself. That the vast majority up to now has been installed in the Asia-Pacific region. China is the predominant leader with 37.6 gigawatt installed capacity in 2021. And policy cluster C is land use, circular economy, and permitting.
Hello, everybody. Welcome to this Sinovoltaics webinar together with BayWa about agrivoltaics. This is our 11th webinar, and we're really glad that you joined us here. I can see there's already a lot of people joining from all over the world. Welcome, everybody. So the webinar will be around 40 minutes. After that, we have a Q&A session, which may be 5 minutes, maybe longer. First, Max will start from BayWa. We'll start with agrivoltaics market and standardization. Then Nicholas will talk about the quality assurance that's needed for the agrivoltaics. On the practical side, during the webinar, you can ask your questions in the chat on the right. The other participants will not see your name or questions. Those questions we will either answer directly or afterwards in the Q&A. The webinar will be recorded and you will automatically receive the recording later. Then let me introduce you to Maximilian Techtmeier, or Max. Max has joined BayWa in the project development of utility scale PV parks in 2020. Already during his university studies, he was quite interested in agrivoltaics. That's why he did his master thesis on that topic. Now he is the Agri-PV or Agrivoltaics product manager at BayWa. Then we have Nicholas Weimar here on the call. That's the CTO of Sinovoltaics. Nicholas is kind of our technical backbone of Sinovoltaics, and fun fact, he is fluent in Chinese and many other languages. Then me, I'm Benoit van der Maas. I'm the International Business Development Director at Sinovoltaics. I've been working for 3 years for Sinovoltaics, and we help the clients to achieve zero risk in their projects. Now I'll give the word to Max from BayWa.
Thank you very much, Benoit, for the introduction. I hope everybody can hear me nice and clearly. First of all, I'm delighted to know that we have an audience from all over the world, because I do believe that agrivoltaics is going to be a technology applied not only in the APEC region or Europe, but there's actually a vast majority of regions in the world that can benefit from the advantages of combining photovoltaic and agriculture. My presentation today is going to be on markets, standardization, and quality. And I brought these 4 topics. So first of all, agrivoltaics and market development. I'll be giving a brief overview of what the industry and also what science understands under Agri-PV. And you keep noticing that I say Agri-PV. I try to stick to agrivoltaics. Later on that more. The second point is an overview of the key pillars in the market that need to be fulfilled for agrivoltaics introduction. Third, I'll be talking about standardization process in Germany, Italy, and France. And the last slide is going to be an outlook of what to expect in the years to come. So jumping into point 1, agrivoltaics and market development. So first of all, with this slide, or with the 3 slides to come, I want to point out the diversity of the term and the technology agrivoltaics. So what is agrivoltaics? There is a quote from the research center Fraunhofer in Germany, Fraunhofer Institute for Solar Energy Systems, that says agrivoltaics is as diverse as the farming sector itself. And the bottom line is that agrivoltaics understands itself as a technology to dual-use land for main agricultural purposes and secondary solar electricity production. Why is that distinction important? That distinction is important in order to avoid phenomena like pseudo-agrivoltaic. On these three pictures that you can see here, I brought a selection of different systems where you can imagine PV and agriculture together. On the left, you see animal husbandry, in this case cattle husbandry, with PV trackers that are elevated over the animals. The picture in the middle is a fruit farm. It's a cherry orchard covered in photovoltaic panels. These photovoltaic panels here have the advantage that they, of course, harvest renewable electricity, but they also protect the plants from extreme weather events. They prevent rainwater to get to the cherries, which in turn reduces the need of certain fungicides and pesticides. And on the right-hand side, you can see a interspace cropping system where a farmer is growing corn in between rows of ground-mounted photovoltaics. This table here is a classification scheme of also Fraunhofer ISE. I use this one because they do state-of-the-art research in agrivoltaics, and this is also here to show you the vast diversity of agrivoltaic systems. So first of all, you can classify agrivoltaic systems between open and closed ones. And I go down the line of the open first before we go to the closed ones. So within the open systems, we have interspace and overhead PV. Interspace is what you saw on the right picture in the slide before, where you have PV panels installed in such way that agriculture can happen between the module tables. And here, of course, we have the possibility to apply fixed tilt systems, but also one-axis systems. One-axis tracking systems have the advantage that you use less of the land for the PV installation. But also the farming processes that you can use with these systems are different. So it can go from grassland farming to arable farming, corn, cereal, potato farming, dairy, meat production. If we look into the overhead PV systems, there's also the possibility to integrate fixed tilt systems or one-axis tracking systems, also two-axis tracking systems. And also here you can go for arable farming, but also horticulture. In horticulture, we made the experience that certain types of fruit and vegetables work very well underneath PV panels. We did a lot of testings with different transparency grades of panels. We used full cell panels with different crops in different regions to really understand better which variety of crops works well with more shading and for which crop the PV panels can actually produce synergies. If we look into the closed systems, the most famous application would be PV greenhouses, where you instead of only having a glass roof for greenhouses, have PV panels. They can also be full cell. They can also be semi-transparent, and there's also a whole bunch of applications where you can use PV greenhouses. One question that we might discuss upon later is Agri-PV also photovoltaic installed on buildings in the farming sector, where the farm, for example, self-consumes the electricity? It's used in agriculture. It's deployed on agricultural land. Science is not, there is no 100% consensus on that. But next to the diversification of Agri-PV in terms of technology, there is also the question of the intensity. So agrivoltaic systems can produce synergies with agriculture, and this, of course, is the core of the technology, that you protect crops, that you actually make crops grow better than under full sun influence. And here we would be, for example, at the overhead systems. And the further you go out in this circle on the right side, the less are the synergies with agriculture. But you can still see here systems for crop production. You can see PV greenhouses, systems with animal husbandry, aquaculture, biodiversity PV with ground-mounted parks, beekeeping in ground-mounted PV parks, but also opaque buildings and indoor farming can be considered as Agri-PV. So within these last 3 slides, I really wanted to catch your attention to understand that there is not the one Agri-PV technology or agrivoltaics technology. And all applications that we have seen are suggestions of how to use PV and agriculture on one area. And one type of technologies produces a higher amount of synergies, other technologies produce a lower amount. And I think industry and science is going to find the best fitting ways. If we look into the agrivoltaic market, I want to draw your attention to the graphic on the right of this slide. You see a world map where it's depicted how much capacity of agrivoltaic systems is installed in the world, and we can really see also in this red circle here that the vast majority up to now has been installed in the Asia Pacific region. China is the predominant leader with 37.6 gigawatt installed capacity in 2021. There we come to one market driver for Agri-PV or agrivoltaics, which would be governments pulling red tapes on certain PV applications. So in some regions of China, it is not allowed anymore, or you won't get permission anymore for installing ground-mounted photovoltaics on arable land. And there, of course, you need to be creative as a project developer on how to dual use the land. And the second biggest share of installed capacity worldwide is in Europe, where we have growing markets like France, Italy, Germany, and Austria. I'll be talking about the former 3 in a couple of slides from now. But there are also some US states that implement Agri-PV support schemes. And another key market driver for Agri-PV is the global food, energy, and water crises that happen, and the technology which is able to really tackle some challenges here. So, for example, there's the possibility to integrate water harvesting systems on the PV modules, and which make you able to catch the water, save it in water basins next to the plot of land, and later bring the water back to the plants via drip irrigation, for example. But they can also bring frost protection. If Agri-PV was installed on only 3% of the cropland in the European Union, we could achieve 1 terawatt peak installed capacity of agrivoltaics, which would be even more than the total EU PV goal by 2030, which is determined to 750 gigawatt peak. If we look into the market development for the next 5 years, we are here at 2022. You see some 6 gigawatt installed capacity, and in 5 years from now, the market is expected to have grown to over 40 gigawatt peak in total. Most of it expected to be in the APAC region, so Asia Pacific, but also Europe and in the United States. Let me now come to my second point, the key pillars to introduce agrivoltaic in a market. And here, I beg your pardon, the slide is focused on EU level, but it'll also apply to other markets, because here I'm going to talk about legislations and policy framework that really needs to be in place in order for the agrivoltaics to be implemented. So policy cluster A is farming and rural development. In the European Union, there is the common agricultural policy, which is doing payments to farmers that do agricultural activity, and there's payment being made by the size of the plots of land they're active on. But there's also payment made for ecological measures and biodiversity measures. Policy clusters B is energy and energy policy and climate protection, and policy cluster C is land use, circular economy, and permitting. So basically, if you want to deploy agrivoltaics in the market, you need to, from the energy policy side, have incentives by governments in order to come up for the risen costs. So, for example, when you have interspace systems, you will increase the space between the PV models. That means your cabling cost is higher. You also have to be careful when you install the panels in order not to harm the soil. And a governmental incentive from the energy policy is really beneficial for that. But also the permitting question is important to consider, because as of now, in all European countries, policy is known to us. If you want to deploy agrivoltaic systems, you still need to re-sign the land from agricultural land to commercial or industrial area. And of course, there's a question of why do you have to do that? Because you still have agricultural main use and secondary PV use. So also here, if a policy framework allows for PV to be installed on farmland, this will facilitate very vastly the deployment of agrivoltaics. And also here, we have the case in many European countries that farmers don't get their European funding anymore once they use solar electricity on their land. But this doesn't take into account that there is technologies such as agrivoltaics that combine the land and that doesn't hinder agriculture, but that actually creates synergies with agriculture. So if there was a vast implementation of farming fundings to be given to farmers when they have agrivoltaic systems, this would also facilitate the introduction of Agri-PV in markets. As of now, to us, there is no market known where all these clusters coincide, but we see many developments going on. And in order to be able to make incentives from energy policy, or in order to say, yes, okay, we leave your land as agricultural land, governments also need to know what type of technologies they do that for. And therefore, standardization is really key. And now I'm going to talk about standardization schemes in Germany, Italy, and France, which are the first 3 countries in the European Union to have introduced standardization schemes for Agri-PV. Starting with Germany, there is a quality standard called DIN Spec 91431, very beautiful German abbreviation. And in the following, I'll be introducing the key factors of this standardization document to you. So if you look on the right-hand side of the slide, you see that the standardization document is diversifying Agri-PV between 2 categories. There's Agri-PV category 1, which is really dual use of farmland or overhead PV, and category number 2, which allows for parallel use of land. Category number 1 is defined by elevated panels of at least 2 meters 10. This has to do with safety issues, because you want humans to operate underneath the system. So clearance height must be at least 2 meters 10. And here, both fixed tilt and tracking systems can come into account. As you saw on the slide before, when I talked about the schematic diagram of agrivoltaics, you can basically imagine any type of crop to be grown underneath here. It's always a cost of it's always a question of co-benefits of the farming activity and also of the costs that are associated here. Because as you can see, you elevate the panels. That means you have more steel, and also for our systems in fruit voltaic applications, we mainly use semi-transparent panels that have a higher cost per watt than opaque panels. Then there is category number 2, which is defined as ground mounted. And also here you can imagine fixed tilt systems, you can imagine vertical systems, and you can also imagine PV tracking systems. Also here you can grow any type of crop between the two, between the module rows. But category 2 definitely produces less synergies with agriculture than does category 1, or say at least not as much is known of the synergies from category 2. Worldwide research has rather focused on the overhead PV applications. But apart from defining the 2 categories, the DIN spec also makes some quality criteria that have to be met for a system in order to be considered as an Agri-PV system. So at least 66% of the agricultural yields must be maintained, and this needs to be approved by an independent expert. And a maximum of 85% of land must be obtained when you install a PV system on arable land or on cropland and you want to call it agrivoltaic systems. They make a differentiation between category 1 and category 2. In category 1, there is a maximum of 10% space allowed that you take for PV, and in category 2 there is a maximum of 15% allowed. Further than that, the standardization document gives out some quality criteria like homogeneous light distribution needs to be met, the water management needs to be thought over, agricultural machinery must be able to pass through or below, construction logistics must be carried out in such way that you don't harm the soil, and it's also talking about some other parameters. There is always going to be a novellation of the standard document. We do believe that in 2023 there will be the process for the next novellation, and there we want to integrate solar greenhouses and also animal husbandry. As of now, there is no EU-wide standard, and you will see in the next 2 slides that this can be kind of a headache because when I move to the Italian standardization document, you see already that they do not define only 2 categories, but they do define 3 categories, which are fairly similar to the ones that the German standardization document has done, but not exactly the same. So category 1 in the Italian document also talks about dual use of land, of elevated PV panels. Here again, doesn't matter whether they're fixed tilt or if they're with PV trackers. Category 2 is talking about the first form of the parallel use of land with fixed tilt systems or tracking systems, and they have created an own category for vertical fence installations. Apart from that, there's also a couple of different things where this standard is deviating from the German one. So instead of being able to only occupy up to 15% for photovoltaics, the Italian standard allows to obtain up to 30% of the agricultural land, which is of course beneficial for PV developers because you are simply able to install more capacity on a hectare than you are in Germany, but you can still call your system agrivoltaic system. The document speaks about a panel density that is allowed to be no more than 40%. This is similar to the ground cover ratio, but not exactly the same. And the document also makes a stake on animal husbandry, because it says, okay, the minimum height for crop growth in category 1 for overhead systems need to be 2 meters 10, but for animal husbandry the minimum height needs to be more 1 meter 30. And here we could imagine, for example, sheep keeping, or also chicken, duck keeping in combination with PV. Just as the German standardization document, the quality criteria here as well are equal light distribution, water management, the system that needs to be in line with agricultural machinery used, construction, logistics, and also soil quality. Another important difference is that there is no independent expert opinion to be needed. Italy is going to release soon their guidelines in the Renewable Electricity Act on how agrivoltaics is going to be incentivized by the government. But as of now, there are only drafts out, so there is no there's nothing clear you can say about the funding of Agri-PV in Italy. What we know is that probably only farmers and farming associations are going to be eligible to receive the funding. And the funding can either be a CAPEX funding of some percent or a feed-in tariff. If we look into the French standard now, you can see that the slide looks already very much different, because the French standard does not standardize categories. They do not pose limitations on land that can be occupied for photovoltaics. But what they do, they have certain quality assurance criteria to which they give a certain number of points, and the project that reaches the highest amount of points is after this standardization document the most sustainable agrivoltaic project. The French funding mechanism does not include these criteria yet, but what the French funding mechanism does is they have a tender for innovation where PV parks with a maximum of 2 megawatt peak can participate. And in the past, we've seen that market participants have been successful by applying with agrivoltaic projects and got funding of up to 95 euros per megawatt hour. So what are the points here in the French quality standard document? Well, first of all, it's agriculture. There are questions asked like, are agricultural needs adequately considered? Do farmers participate financially? They also give out points on the reversibility of the system. There, the question is basically, can the system be removed without problems? Will the soil be as fruitful as it was before? One other criteria point is the landscape. So how does the system fit into the landscape? Were local actors and community consulted and involved in the planning process of the system? It's talking about the impact on soil. Again, here, is the system designed in such a way that the soil is not going to be harmed? And is soil degradation prevented, which is a really important topic in agriculture. It talks about the impact on the environment and farmers. It's basically the question whether the project is beneficial for the environment. Does it support biodiversity measures? And the last 2 points talk about the adaptability of the system and the technical flexibility. So can the system produce the same agricultural production with and without panels? And is the system adapted to potential technical development? So the question is, if in 5 years from now there is a new state-of-the-art technologies for panels, for example, will the system be designed in such a way that that the newest technology can be employed in the system? I forgot to mention before that I want to do now the German funding mechanism. Therefore, I jump back to the German standardization document. So in Germany, Agri-PV had been funded since 2021. First, also in an innovation tender, where you needed to combine an Agri-PV system with a battery storage system or with a wind park with the size of maximum 2 megawatts. So the battery storage system was the most plausible one. But this has moved now. There had just been a novelty of the German Renewable Energy Act, which is going to be applied in 2023, and from there on, agrivoltaic systems which are built after this DIN spec documentation receive the same funding as ground-mounted systems, so they compete in the same segment. But for highly elevated systems, which refers to Agri-PV category 1, there is a bonus going to be paid of initially 1.2 cent per kilowatt hour. And for the category 2, there's no bonus to be paid, but for both categories, the Renewable Energy Act opens up the area where it's possible to get the funding. So for ground-mounted systems, you can get the funding for conversion areas or areas next to highways or train tracks. But now, if you build agrivoltaic systems, you're actually not restricted to these area categories anymore, but you're allowed to go out in agricultural area. To sum up and give an outlook on my last slide, as I said in the beginning, the most interesting markets where we will see vast deployment of agriculture will be in the near future APEC. They are predominantly China, India, and Japan, but also European countries are taking up pace by introducing funding mechanisms. For example, Germany, Italy, France, the Netherlands, or also Austria. Growth drivers that we see now, but that we will also see in the future, and probably even more due to climate change, are innovation of new technologies, for example, transparent solar panels, OPV panels, rising water scarcity around the world that reflects back to what I mentioned before on the water, energy, food nexus that is possible to be tackled with Agri-PV systems, but also an overall inclination towards renewable energy and climate change, which poses a lot of challenges to the agricultural sector, which needs to be creative to adapt to new situations. In research, there has been a lot of research on crop voltaics. I guess we will be seeing a lot of more on both fruit voltaic and crop voltaic. This is due to the fact that of course the results to be achieved with a certain type of fruit or a certain crop vary very much from region to region and also from year to year. But we will also see some more research in solar greenhouses and overall on PV panels and substructure technologies and components that make the agrivoltaic system just more efficient and even to be more integrated into agriculture. This was my last slide. Thank you very much for the attention. I guess you will be getting the slides, and if you want to reach out to me after the seminar, here you can find my contact details. Thank you very much, and I hand over to Niklas now.
Yeah, thank you, Maximilian, for your very great presentation. And obviously, Agri-PV has, while being a formerly rather minuscule niche subsector, has grown to nowadays to a multi-gigawatt subsector within our solar PV industry family. And now, as the next topic, following Mark's presentation, since Agri-PV is on track to become, I would say, the 21st century's potent solution to mitigate land use conflicts between power generation and agriculture, between energy security and food security. So it's also important to have a look at the key aspects of the quality security side of successful Agri-PV projects. So generally, qualification and safety tests for PV modules and other components apply also for such equipment that is being used in Agri-PV applications in general. Yet the PV equipment used in Agri-PV applications needs to meticulously meet mechanical design and workmanship requirements. So so as to not only obstruct its proper performance, but also not to impact and endanger the proper health of the crops and livestock that are attached to these projects. One key requirement for PV modules in certain Agri-PV setups is that they are designed and built resistant against corrosion from ammonia. So ammonia corrosion refers to corrosive attacks on the material that is caused by the interactions between it and the ammonia. So it is a chemical compound which consists of hydrogen and nitrogen, and it has quite a pungent smell. It's a byproduct of decomposing excrements, and it is thus very prone or attached to environments with livestock and livestock waste. With ammonia, is not that well. Ammonia itself is actually not that corrosive in itself, but the corrosion issues, they may happen with some materials, and especially when there are contaminants present, such as so basically they could affect the materials like copper, zinc, and many alloys. So for this reason, and over the years, standards and testing procedures have been developed to stress test and certify modules designed to withstand such effects from ammonia corrosion. And most prominently is the standard IEC 62716 in its latest edition, currently from 2013. And this standard describes test sequences useful to determine the resistance of PV modules to ammonia. For PV modules employed in such Agri-PV project environments, certification to this standard is of critical importance. And as a next point, depending on the project application, not only the qualification to such standards relating to Agri-PV basically setups is important, but also a check actually on the suitability of the certified bill of materials, basically. So the engineering bill of materials is an important factor. So an example is to assess whether, for example, materials with a toxic content are being assembled that may pose a risk to livestock and even crops, especially with the risk of leakage of operating materials. So one example that we have also we could also cite, for example, for other applications that are like water-based or close to water, like for example floating applications, is when string or cell interconnectors are being used that have with a certain lead content. So that would be then a factor to consider or to read the bill of materials for this module being used in such a project. Then, having established basically that the design of a module is fit for purpose, then so we'll have a look at the critical checks and tests that need to be in place when PV modules are produced for projects or Agri-PV projects. So common workmanships, and again, similar to the reliability tests and performance tests of PV modules used in non-Agri-PV projects, they also apply, of course, to Agri-PV projects. So these include standard checks that you would do at the factory is executing, like visual inspection, like maximum power measurement, electroluminescence imaging. But you want to make sure that the proper quality state of your modules is in place, basically, so to prevent early replacements down the line, especially on farmland, where such replacements, in the worst case, may have an impact on the crops or soil. So in the worst, and you may probably even be forced to wait out for example, for periods or times when the soil is actually dry. So, and then that would cost you also valuable time. So it's even more here of critical importance to make sure the proper quality state of the equipment, in this case, for example, modules, is in order. Then, however, since the PV modules are used alongside crops and livestock, so it is important that the modules are not only compliant on datasheet papers, but essentially also in manufacture, and thus meet the engineering bill of materials one-on-one. Key checks that our quality engineers meticulously also monitor during the production on-site at the factory include that the certified materials, importantly encapsulants actually, are assembled as certified. Aside from material compliance checks, the assembly itself also must meet certified design requirements. One example that we could cite here includes the case of cell alignment and cell gaps, so which must be compliant so as to ensure that there's proper light homogeneity. This is also then easier to implement by factories with a more advanced automated layup setup vis-a-vis those with predominantly manual setup. So when you work on Agri-PV projects, our team at Sinovoltaics has a long track record in Agri-PV specific component, technical compliance and quality assurance, and is glad also to support you here. Now, that is the end of the quality chapter, and we could now move to the question and answer session. Thank you very much.
Thank you, Niklas. So if anybody has any further questions, you can type them directly in the chat. Now we will go over the questions that were asked earlier. So we have a question here from Colombia. Maybe Max, can you answer this question?
Yes, do you want to read out the question, or?
Oh, people can see it on the screen now. So.
Okay, fair enough. Well, I just repeat also for myself. So the question is, what about the efficiencies of the Agri-PV system compared to standard system? What are the installation costs? Does it work for any type of plantation? Why is it starting to be so important? And do we have any numbers for South America? Okay, I'll be starting with the latest question. I don't have it in my head now, but you can check when you have my presentation, the first slide, or the fourth slide, I think it is, with the market share. There has not been much happening in South America yet. I am aware of 2 systems that have been installed. One of them is at Fraunhofer, Chile, and the other one has been installed in Brazil. But what I know is that there is more and more interest and also requests coming in, which we try to serve with our partner network, really, in South America. Well, why Agri-PV or agrivoltaics is starting to be so important is basically what Niklas touched base upon. It's the fact that this technology is able to tackle land use conflicts and also adapt farmers to climate change by both facing challenges that climate change poses on farmers, for example, extreme weather events, hail, drought, and you can just a clever designed Agri-PV system can be a system that is doing water, energy, and food harvesting at one time. And since world population is rising, which creates more pressure on agricultural areas, and especially fruitful agricultural areas, there is a need for the countries that have these fruitful areas, but need to meet their climate change goals, their climate targets, to deploy systems that go away from the monofunctional thinking, but rather look into dual function. Does it work for any type of plantation? Well, theoretically, yes, but to be very frank, it's just too little known on that. So we as BayWa RE, we have installed systems on raspberries, blueberries, apples, pears, what else? Cherries. So there's quite a couple of crops that we have worked with. Also wheat, so winter wheat in Austria, and we keep getting more and more insights from the results. But there, also to be frank, most of the systems have been developed in the Netherlands, and that means we will be getting results for the climate of the Netherlands, for this variety of the crop, for this special year, and with this certain technology. What I want to say with that, we always want to broaden our knowledge on crops and on geographies at the same time. And I think there will still be a way to go for us, but also other market participants in science, to really be able to point out the crops that are best suited for Agri-PV. Generally, you can say, well, yeah, there is quite a lot known on the shade tolerance of some crops and the shade tolerance of others, and of course the crops that are most shade tolerant work best with Agri-PV. And now, okay, what are the installation costs? Depending on the system. So I'll be talking about 3 systems now. Number 1 is Fruitvoltaic, so PV on top of on orchards with semi-transparent panels. Let's say elevated to 3 meters height with a pole distance of 4 meters or something. You can assume 70% more of what a ground-mounted of a similar ground-mounted system of the similar height would similar size would cost, simply because of higher elevation, higher labor costs, and semi-transparent panels. For, let's say, PV with trackers and cows underneath, as I showed you before in the picture as well, I would assume some 30% more capex than for a ground-mounted system. And for interspace PV, I'd assume, or we calculate with 10-20% more costs than for ground-mounted photovoltaics. And what the efficiency of agrivoltaic systems compared to standard systems, I think I don't really understand this question really. So this will also really depend on the technology that you choose. For the fruit voltaic systems, for example, that we have deployed, we install around 700 kilowatt peak on a hectare, and we can see that we have a higher bifacial gain through the panels being higher elevated and more diffuse light going to the back of the panels, and also the evapotranspiration by the plant cools the panel, which actually gives a slight increase of the efficiency. When you look into crop voltaic systems where you really have, for example, PV tracking rows that are put far apart from each other, you will also have a higher specific yield in kilowatt hours per kilowatt peak, because you simply don't cause shading on the panels by other panel rows. Yeah, hope I got to the most points of that question.
Okay, let's see for the other questions. Maybe this would be a question for Nicholas. How much aluminum is used in framing and mounting, and how does this work with ammonia resistance? You're on mute.
Now everybody can hear me.
Yes.
The question doesn't relate to basically to a project or like what kind of to certain projects, or how's the question? How's the question phrased? So I mean, you have in many of these structures you use mostly actually aluminum based framing or mounts basically, and and yeah, and they're of course also exposed to these factors, and as well they would also actually, yeah, they did also need to basically be designed, certain in a certain way basically to withstand these kind of environments due to these gases basically that are in this kind of environment. But how much? I mean, I do not know how this question is being meant on a project level scale. I could only estimate it's probably majority of projects to use this kind of material as mounts. But yeah, maybe Max has a little bit more of statistics on this one from your own projects, but I find it hard to put it into numbers.
It is really hard to put into numbers. I confirm what Niklas says. Again, depending on the technology very much. And well, otherwise, I mean, you need to take into account that the system needs to be more stable because, for example, elevated panels, and it needs to withstand the wind load, really. But it's really difficult to put in numbers. I would even say kind of impossible.
Okay, thank you for answering. Then we have another question from the USA. So this webinar has mainly been about standardization in the EU and specific countries. So maybe Max, do you know if there's any progress in the USA to promote and facilitate Agri-PV?
Yes, I know that the state of Massachusetts, which is a name I have a hard time to pronounce, has facilitated permitting of dual-use PV applications on farmland and PV. And very recently, there has been a national call for agrivoltaic solutions. The US government is promoting agrivoltaics right now with $8 million, and this is not dependent on the state. And to my knowledge, it was possible to apply with projects. But here, that's interesting because there has not been a standardization process for agrivoltaics in the United States. That means also ground-mounted projects where there is a beehive could participate, or also sheep, like solar grazing projects where there's sheep keeping in ground-mounted parks can participate. I guess in the United States, there is still quite a process to be made to define what agrivoltaics is supposed to be in this market, really.
Okay, thank you, Max, for that answer. Then there's one last question from Bangladesh. So they're wondering if you can use this on a grid system. Is that possible?
So if I understand the question right, the question is basically whether you can feed the electricity into the grid. Benoit, would you?
I think that's probably the idea, right? That so there's again like the solar sharing application of farmland and Agri-PV, and then basically you would use that electricity to feed it basically back to the grid. That's also my understanding of that question. It's always a matter of the infrastructure, but normally speaking, yes, of course.
Okay. Then here you can find our contact details. If you have any further questions, you can contact Max through his email, or you can also contact us from Sinovoltaics by email. Thank you everybody for joining, and please contact us if you have any more questions, and we will be glad to help you. Thank you very much, and see you in our next webinar.
Thank you also from my side. Bye-bye.
Thank you. Pleasure. Bye-bye.
Visit Sinovoltaics.com to learn more.